For number 16 and number 17, you're using algebra to change the equation from this form, which is point-slope form, into slope-intercept form. So this is point-slope form, because to write it, you need to know the point, a point, and the slope. And this is slope-intercept form, because to write this equation, you need to know the slope and the y-intercept. So, but it can be handy to go from one form to the other. So that's what we're doing here. We're going from this form to this form using algebra. All right, so let's do it. So the order that you do these steps doesn't have to be exactly my order, as long as you don't break any of the rules of algebra. So on one of them, I'm going to use one approach, and then on the other, I'll use a different approach, and you choose which one you want to do. Now here's a note down here. This is important. If you want to, you can put your beginning equation, the starting equation, and your end equation into Desmos. And if they match, if they give you exactly the same line in Desmos, your work is correct. All right, so let's do this. So on this first equation, what I'm going to do first is I want to get y by itself, because see how y is by itself here? So I want to get y by itself. So what I'm going to do to isolate y is I'm going to add 6 onto both sides of the equal sign. So if you draw a line here to kind of show where your equal sign is, I'm going to add 6 on this side, and I'm going to add 6 on this side. Right? So, but personally, the line gets in my way, so I'll erase it, but if you like it, you can keep it there. Now we have only y over here. See, because 6 and -6 added together is 0. So now what we have left is we have 3 times x minus 1, and that's in parentheses, plus 6. All right? Now the next step I'm going to do is I'm going to distribute. So what that means is I see this 3 outside of the parentheses, and I'm going to multiply it by everything that's inside. So I'm going to take 3 times x, and I'm going to take 3 times -1. Okay? And that's going to give me y equals 3 times x is 3x. 3 times -1 is -3. And then I'm just going to bring down my plus 6. All right, so now the next step, and the last step we need to do, is to combine like terms. So I am not allowed to add together and combine terms that have a variable with terms that don't. This is a variable term. We've got a variable and a coefficient. These two terms are what's called constants. They don't have a variable visible. So I'm going to combine these two constants together. And -3 plus 6 equals 3. Now, if you kind of panic when you see positives and negatives, think about it this way. So make yourself a t-chart, have a positive side and a negative side, and then see how the -3 has a negative. So I'm going to put the 3 on the negative side. And see how the 6 has a positive? So I'm going to put the 6 on a positive side. So if these two were on the same side, I would add them together, because like they're working together, they're becoming more powerful. They're opposite sides, so they're kind of fighting against each other. If they're on opposite sides, you're going to subtract. And then look at the more powerful number, the 6 or the 3. Which one's bigger? The 6 or a 3? The 6 is. So then look at the sign of the bigger number. It's positive. So when you add these two numbers together, they equal 3. So that leads into our final answer here. We have y equals 3x plus 3. The reason I sometimes like to show people how to do it by hand is once you practice, it's faster than a calculator, honestly. But also, it's so easy when you're using a calculator to make mistakes with signs because every calculator is different. So the most reliable tool that you have in this circumstance is your brain. Your brains are much more reliable than your fingers pecking at a calculator. So I recommend that you at least know how to do it in your head or on paper so that you can make sure that you're not typing the wrong numbers in a calculator. So, all right, so now if you wanted to, you could type this and this into Desmos on two different lines, and you would see that they're exactly the same. So let's do that. So check it out. Here is our first line, our y minus 6 equals 3 times x minus 1. And then here is our other version of the same line. And if you look, see how it's exactly the same line? That shows that we're right. Now let's do the same kind of thing, except I'm going to show you that the order can be different, okay? So last time we added 6 first to get rid of this negative 6, but this time I'm just going to let that positive 3 ride. Okay, I'm going to leave it alone. And instead, I'm going to make the choice to distribute first. So I'm going to multiply negative 2 times x, and I'm going to multiply negative 2 times negative 5. Because guess what? When you are doing algebra, it doesn't always matter which order you do things in as long as you don't break any rules of algebra. There can be ways that are easier, but you often have a choice. Okay, so when we distributed, we got negative 2x plus 10, because negative 2 times negative 5 is 10. And now I'm going to do that step where the opposite of plus 3 is minus 3. And remember, if we subtract 3 over here, we need to subtract 3 over here. And because I know that 10 and negative 3 are both constants, I'm going to line them up. Because I know that this negative 2x is not a like term, but these two are. And now these equal 0, so we have y plus 0, but I'm not going to bother to write that. And then we have negative 2x plus 7, because 10 plus negative 3 is 7, or 10 minus 3 is 7. So this equation right here and this equation right here are describing exactly the same line. And again, you could pop into Desmos and you could put this equation in Desmos and this equation in Desmos, and if we did our math right, they'll be exactly the same line.